Welcome everyone to the Ontology Summit 2024. Today is February 21st, 2024, and this is the first session, kickoff session of the main series in the summit. The topic of the summit this year is neurosymbolic techniques for and with ontologies and knowledge graphs. It's not giving me the next slide. That's a problem.
It's a PPT file. You should be able to do it.
Yeah, let me go at it again. All right, so I want to welcome everyone. Our summit is going to survey current techniques that combine neural networks with symbolic methods. And of course, we're going to be emphasizing ontologies and knowledge graphs. Now, the fall series already explored similarities and distinctions between ontologies and LLMs. What we're going to do now is more general, dealing with neurosymbolic techniques, not just LLMs, and especially how one can leverage the complementary benefits. And our agenda today will begin with memorials, and then a review of what happened in the fall series. And then we're going to have a series of track overviews, and then looking into the future for the summit. I'm really sorry to tell you that one of our really very productive members of our community has passed away, Matthew West. He has contributed in numerous ways to the forum and the summit. He was a general chair, track chair, session chair, panelist, speaker, co-authored on numerous occasions, and has been with us since the Ontology Summit in 2006, the very first one. He was a founding member of the Board of Trustees, and he was our membership chair, overseeing the development of our community from just several hundred to the current number of around 1,400. So you can see more about him on his namesake page. I'm also sorry to tell you that Doug Lennett has passed away. Doug Lennett was also a great contributor to our community. He's been contributing since 2005. He was actively involved in the very first Ontology Summit, dedicated to making our ontologies interoperable. He made considerable contributions as the founder and CEO of Psycorp, and he spoke with us on numerous occasions about Psycorp and the lessons that he learned. For more about him, see his namesake page. So now we'll have a little review of what took place in the fall series. This was co-chaired by Mike Bennett and Andrea Westernen. The topic there was ontologies and large language models, related but different. In that series, we learned how the use cases, strengths and weaknesses of LLMs are complementary to the strengths and weaknesses of ontologies. So here you see the number of the use cases and strengths of LLMs on the left, or information extraction, summarization, classification, content, but it has many weaknesses, like it has difficulty in maintaining coherence, doesn't tell you anything about the provenance of what it is telling you, doesn't understand anything about the semantics, can't explain what it's telling you, and doesn't make any kind of logical reasoning. But all of these weaknesses align well with the ontology capabilities. So if you combine the two, you can overcome the weaknesses of each. So that then becomes a question of how you achieve hybrid system capabilities. So this lists a number of ways in which one can do this. And Gary, in just a moment, is going to be giving you a great deal more about the capabilities of hybrid systems involving LLMs and ontologies and knowledge graphs. So I won't dwell anymore on this issue. So the fall series discussed hybrid systems, provided motivation for developing them, and demonstrated some applications based on them. So I encourage everyone who hasn't seen those presentations, and they have all been recorded, and you can get them, the videos for them, as well as the discussions that followed. They highlighted the need to keep exploring areas of collaboration and improving both of them. And they show different interactions. So today, we're going to be talking about some of these, and the first track of the main series is going to be on architectures and foundations. The fall speakers began by setting the stage with Deb McGinnis. Then there was a look across the industry by a number of individuals who've been active in this area. Kurt Cagle, Tony Seal, Everett Sirin, and Yuan He. Again, make sure that you check out these if you haven't attended those sessions. We also had a couple of very interesting demos by Prasad Yalamanchi and Andrea Wisnarinen, who is active in this area of hybrid systems. And we had some broader thoughts about this, and they were going to continue to have discussions about this in the main series. But in the main series, we hope to be a little broader with respect to the AI techniques in the neurosymbolic area. Now I'd like to switch over to the track overviews. Ravi, would you like to take over now? If you can't bring up your slides, I can do that for you.
Now I can. Yeah, well, I can share screen if it's okay.
Go ahead.
Let's see. Is that visible to everyone?
Yes, very good.
So, neurosymbolic AI is a new field for me to learn on, but it is, as I get deeper into them, these areas, I am able to connect whatever I know about ontology and associated summits that we have had. I am able to weave together a thread and understand how profound changes are being made by combining what happens in human mind with what the machines can do and how logic and uncertainties play their role in automated solutions that are trying to solve many good problems and are also creating some new ones. So I've been given the responsibility to think about and talk about foundations of neurosymbolic AI with ontologies and knowledge graphs and architectures. Well, it's a work in process, but we will begin with an attempt to start to glance into both these areas. The next slide, I guess I have to do this. So the summit, as I mentioned in the first paragraph, is going to address the three things, namely information, human and machine learning, and also there is a interplay with engineering because the robots are coming on the scene, and there's tremendous movement in making public the solutions using the software techniques that people are working on in solving parts of the multiple domains that are involved in such a complex subject. So, deep neural networks tend to simulate learning and reasoning. These are two important areas of neurosymbolic, the neural part of the neurosymbolic. And then visualization using scalar, vector, and tensor symbols are being done. Scalar does the text processing, NLP, and classical LLMs that Ken just mentioned and Andrea covered in the fall series. The vector part is being used often for image processing or pictures processing. The tensor part is even more interesting. The whole concentration is by all these techniques, how much does the automated technology and information technology actually understand? Our mind works in a very complex way, and if parts of how our mind works can be projected on a canvas and given to a machine to learn. Now here people who have thought about this problem for a long time, like John Sova, would say we're not even at a level of learning like a child or like a private yet in terms of intelligence and understanding. But AI is making all types of claims recently, and some are also misuses. So, the foundations of such a complex interplay of multiple domains does involve maturity in each of these subdomains or domains that are encompassed by the subject of our summit, which itself is complex. Therefore, differential maturity of each domain does pose challenges in integration into addressing really the subject of the summit. So, yes, we are used to Gartner life cycles, hype cycle, and life cycles of each technique or solution. They matured at different times and they are in different stages of maturity. So it's not just sum of parts. it is more complex than sum of parts. Hence, this very interesting field is our challenge in this year's summit. I'm coming to a little bit of addressing the recent focus on visual searches and visual understanding in large archives, databases, collections, web. You can certainly query the web and get some ideas. And so far, a lot of effort has been going into text-oriented symbols. So now visual cues and visual searches are picking up. Even LLMs are beginning to address this through tensors and vectors, and more we will learn. Say, for example, from John Soa, who will be talking next week to us. And further challenges and opportunities are emerging due to these soft factors which I list, namely social media, biases, ethics, undesirable and unintended consequences, and associated risks. And our colleague Mike Bennett would be talking about some of the risks later in the series. Of course, I'm posing a very far out, but not so far out actually, is how our digital computing would get impacted with quantum computing and how it will affect the areas of AI and cybersecurity. Just some thoughts. I cannot cover total field because it's some of at least 3 or 4 very large domains. One of them is deep neural learning, for example. Therefore, I'm just quoting you now what other people I found in very cursory searches, what other people are doing. So here are some thoughts. They talk here about the structure of grammar and Noam Chomsky's universal grammar model for natural languages. Kyle Hamilton's paper continues where he refers to work of Gary Marcus, who will speak to us next week. Pascal would provide all types of inputs during the series. And Louis Lamb has spoken to us in 21 Summit. John Sova, Ram Sriram, and others are referred just in this one reference that I am giving you. There are many such searches. If you do on our subject of the summit, you will find. This is a review of 50 studies. This paper by Louis Lamb, one of our earlier speakers, quotes. It's a big quote. Marcus's statement is quoted, and then symbolic manipulation of variables in logic and the compositionability of language is discussed. So machine learning and AI. Here is another example which cites a lot of work of Amit Sheth, who will be one of the speakers later in our series. And here various elements of what the source is, depending on type of source, whether it's text, visual, scenario, image, speech, etc. Depending on that and the processing of it gives us, through embedding and so on, the required outcome or solution. Here, for example, is a protege ontology depiction of context understanding in neurosymbolic architectures. Just a snippet, just an example, and an associated knowledge graph that comes from it. So this is about visual understanding. Another example of architecture is this. Logic, inference, and reasoning. These are important parts not only of ontologies, but also in these complex solutions that we are after learning about. I know I'm close to my time limit, so here is one industry solution, no particular reference, but one of the leading industries has been in giving us sparkle, bronze, and allegograph effort of Hans Assmann's company. And I thought this nicely depicted our topics for the summit. And here are references from just archive and one or two other places. This is the authors include our speakers, previous and hopefully some this year. Till Moskowski would be talking to us on some future date in March, I think. And she talks of design patterns relating to architecture. On ontologies in explainable AI, there is a paper. And some more recent papers, like in 2024, this year, a couple of papers I'm referring here for visual abstract reasoning, for neurosymbolic reasoner. And so you see the efforts at foundational principles, integrating these areas, and also architectures of different types used in creating these solutions are emerging and are more and more. I mean, the number of publications, including relevance to these topics, is easily doubling each year or more. The rate of growth is more. So I'm just welcoming you all to our track A with this introduction and requesting you to interact and contribute, and we will have good number of 2 or 3 sessions devoted to track A, and Ken is going to give us some idea of the schedule. Thank you so much. Ravi Sharma here. Ken?
Okay.
Yes, I hope that you can see my slides. I'm Gary Bergcross. I'm, along with Pascal Hitzler, have organized this second track as an introduction to the new hybrid feel of neurosymbolic computing, particularly with a focus on LLMs, as you see in the diagram, and structured knowledge like ontologies. Originally, Andrea Westrin was going to be presenting this as a follow-up to what had been done in the fall, but she was unavailable for this, so I volunteered to take her place. So on this slide, we have the correspondence between these two things we're talking about, LLMs and ontologies as examples. Displayed on the left is a large language model and some idea of its architecture and implementation. The image on the right side is interesting. It's a high-level model depicting 3 AI components, and it's taken from our 2017 Ontology Summit. And in the diagram, we have bidirectional relationships between learning, which might be via neural nets or symbolic AI, and reasoning. Again, it could be symbolic or sub-symbolic, such as using vector maths. Each of them interacts, and so that learning can influence reasoning, and reasoning influences learning, and both need knowledge for example of like in represented in ontologies. I've included below the image the title of my 2017 track on using automated machine learning to extract knowledge and improve ontologies. The point here is that the relations shown in the diagram have been discussed in our summits in pre-LLM era. So this is somewhat of an update on some of those earlier discussions. What I have in mind is a few slides setting some context for this topic, relating back to some of those prior ontology summits. But first, let me go to, if I can move this, to our general mission statement, which has three major parts as shown here. The first part is to explore and deepen our understanding of ontology learning in the new subsymbolic LLM era. Specifically, we ask, can large language models effectively apply their language abilities to support ontological development and even provide help with things like bottlenecks that we know of with ontology? And can they provide sound maintenance across the life cycle? Currently, we can be sure that things like LLMs help find relevant published resources in various text forms. So a question is, can they automatically extract and structure something useful, given what they can find and process from text? Can they elevate the usual text output into a richer form, such as found in ontology? Looking in the other direction, going down to point number 2, we have the idea of, can we improve LLMs using ontologies and related methods? Of course, I think the answer is yes here. The question is, how much? Can we populate and enhance development and performance of LLMs? And I'll have a little bit to say about that as a prelude to what our speakers will be adding. In addition to these two directions, there's the third related question, which is sort of more of the main theme expressed about this summit, which puts the technologies together. And the question might be, what type of hybrids might be developed? We heard a little bit about that in our fall. Here, I'm going to say a little bit more towards the end of my talk. And one question I have is, what are necessary and sufficient conditions for building the implicitly three-part or three-component view of AI we saw on the first slide? And then the related question is, how might we evaluate such hybrids? Those are important questions to consider. Now, my third slide is just talking a little bit about the approach, which is pretty standard. And we have enlisted a variety of practitioners, one of which is here, Hamid, to discuss LLM ontology and application issues and problems related to them, and present their efforts, their experience, and we hope to stimulate the forum discussion within the broader ontological summit. We hope to contribute to the synthesis and the communication and so forth. It's pretty standard stuff for an approach. Now, here are the three planned talks for track B. I've actually included the talk next week, particularly by Gary Marcus, because it is part of the LLM to ontology conversation. And as we know, Gary Marcus has had a lot to say about the limitations of large language models and what is needed for what he calls robust AI. So we should hear a lot more about that next week, and also from John Soa, who will be co-presenting. The week after that, we're happy to have Hamid Giglu present, and Hamid is here, so he may have some things to say. And I was particularly interested in their development of what's called LLMS4OL, Large Language Models for Ontology Learning. So that will be March 6th. And that will be followed by Fabian Neuhaus, who will present the next week on the 13th of March on ontologies in the era of large language models, a perspective. Okay. So on this slide, I have some promised context. And the first comes from machine learning theorist Leslie Valiant, who pointed to the challenge of what he called intelligent cognitive behavior. It makes explicit some parts of what was implied in that earlier three-part diagram I showed on the first slide. And as he put it, the aim is to identify a way of looking at and manipulating common sense knowledge, that's the knowledge part, that's consistent with and can support what we consider to be the two most important fundamental aspects of intelligent cognitive behavior, which are the ability to learn from experience, the learning part, and the ability to reason for what has been learned. He goes on to say, because we understand these two relationships, we quote, is important, I think, seek semantics of knowledge that can computationally support the basic phenomena of intelligent behavior. So a point I would take away from this is to pay attention to formally defined computational semantics, as well as relations to common sense and intuitive explanations. And that raises issues about how those are addressed within not only neural net implementations, but of course the hybrids that we're talking about. This slide is the first of my context I wanted to share with people from prior summits, so that people who might not have been to our summits might be able to look back if they're interested in some of these topics. And so this was part of my track in 2014, and has a very complicated slide on about ontological engineering. And the only point I wanted to make in this is that now that we are some 9 years farther along, we can look at some non-ontological resources maybe that come through large language models as something to help with the ontological bottlenecks. We know, for example, the LLMs can be trained to code, and some of us have used it to code simple relations into OWL from vocabularies, using what a ChatGPT, for example, may know about a particular field or domain. So one question is, can LLMs be an aid to population? And if so, what changes to the knowledge engineering practice do we make? That's important within our field of ontology. Can an LM act like a willing but mediocre domain expert to get some additional views of a domain? And we will have a talk on something like that. Next slide. Again, from our past Ontology Summit, looking at what was called OntoLearn, which uses a 4-step methodology shown on the right here to discover terms, find definitions, extract some knowledge, information, and update ontologies. So people have been doing similar work with seemingly to this, using more powerful LLMs. And this slide, which I borrowed from Hamid and his team's work on large language models for ontology learning, just shows a follow-up using a zero-shot prompting method for 9 different LLM models and for several OL tasks like taxonomy discovery, term typing, extraction of non-taxonomic relationships. So here. So the effort now is broader and deeper. And outputs, and again, as you saw in this slide, include things like taxonomic trees, but also relationships and axioms. I have another slide from Hamid's work we'll hear a lot more about in 2 weeks, a little bit of their summary. So their empirical results show that foundational LLMs are not sufficiently suitable for ontology constructions when it involves a high degree of reasoning skills and domain expertise. So some simple domains might work well, like a low-level domain expert, but not in the complex ones. And the bottom line is, nevertheless, when effectively fine-tuned, they just might, emphasis that word, might, to be seen, work as suitable assistants, elevating the knowledge acquisition bottleneck. So we'll hear more about that in 2 weeks. Now, I want to show a slide going the other direction. So how ontologies and semantic resources might improve what we see from things like large language model activities. And so I have on the top here, sort of in blue, an overview of the typical process going on from text, that's called the symbols here, via coding as vectors, vector embedding, to decoding on the, and coming out with text on the other end. So it's a chat, so you can ask it a question, it comes out with something on the other end. There are several ways that we can imagine some semantics being added to the process, and the diagram shows one where we apply semantic resources such as ontologies to the training area. So I have a little bit about what we could do there. We could compile symbolic knowledge, first-order logic, object relationships, functions, predicates into it. To do this, however, essentially we changing the input, we also change some of the processes. So instead of using the simple vectors, we use more of a TensorFlow type of thing, and can produce things like structured knowledge coming out more than free text. So we get free constraints and therefore potentially better quality transformer learning. This could be some order of first-order logic representations, not restricted even to if-then rules, which gets translated into initial the initial neural net architecture and its weights that get set. In logical neural nets, the key concept is to create a one-to-one correspondence between neural sets and elements of logical formulas. At least that's one idea about how to do it. For this, we need the richer transformations that tensor allows. And at the very bottom, I also have mentioned something that was part of Ravi's talk, mentioning Katz's ideas about the various types of hybrid systems we have. And this is the one I have here is an example of a type 4 from his. I also have something on the decoder end where we could use other types of AI techniques to make better decoders and so forth. So there's a range of places where things from good old-fashioned AI and ontological work might help. So with that, let me move to a few words on hybrids that combine sound reasoning layers with deep learning. The idea is simple and starts, as you see on the left, with a high-level diagram. Discusses that's the discussion by Moon recognizes that some types of reasoning are going on in both types of systems, and they can be coupled either tightly or loosely here. But the reasoning we know is different from the two parts. We have so-called intuitive or automatic system 1 type reasoning compared to system 2 or reflective reasoning that are different. These are different in nature. In humans, they seem to work in a complementary fashion, so it's very attractive to try to do this within a hybrid system. It still seems like the integration remains quite a challenge, and the belief is by many that both are needed to work on complex problems which aren't satisfactorily solved by purely symbolic or neural means on their own. So my last slide here is to just represent a few of the potential architectures, again, coming out of Gauss's work. So one has the symbolic reasoning on top. And what it does is calls a deep learning system below for particular purposes. Of course, we can imagine the inverse going on, such as a neurosymbolic concept learner where the neural net is on top and calls every now and then for help with symbols that might think are important for further processing. In the lower diagram, there's also a loose coupling of systems via communications, which is a type 2 or DeepMind AlphaGo type of thing. The researchers have talked about developing attention schemas, that is training a sub-symbolic system on a model of attention. So when, according to the model, some pattern of importance reaches a point that gets recognized, the attention model part of the network, the neural network in this case, is trained to communicate to the symbolic part for guidance on the important issues. And for more on this, you can see a discussion of the third wave of AI by Garces and Lamb. Lamb was mentioned before by Ravi as having contributed to us. Well, I hope this is enough to stimulate interest in the upcoming sessions. And this concludes my introduction to track. I've included a page of some of the references here, and hopefully we'll have time for discussion and Q&A later on. So with that, let me stop my sharing and turn it back to our next speaker.
Thank you, Gary. That was very, very informative. Looking forward to some very nice talks in track A and track B. Track A and B will end with a synthesis session. We'll try to synthesize the ideas that are presented in those sessions. And then we move on to track C and D.
Ken, do you want me to show my slides?
Yeah, go ahead.
Okay, let me see. I don't have too many, but let me see if I can.
So Ram will speak about track C.
Ken, can you see me? See the slides?
Yes, excellent.
I'll go into the presentation mode. Okay.
You can see.
You can see it, I guess.
Yeah.
Track C is the applications session, and there are 3 sessions in there. One is on finance, which will be co-chaired by Mike Bennett. The second one is session 2 on manufacturing, Todd Schneider, who's here, and he can chip in. Session 3 is healthcare, which I will be the sharing. So in terms of, so the key question is that you have heard a lot about the architecture in terms of how do you take the symbol structures and how do you take the neural structures and how do you combine. And there are several mechanisms of doing that. You can call from the symbol structure, the neural structure, from the neural structures to the symbol structures, and a combination of these things. And Gary and Ravi mentioned these things before. So now the question is that how do you actually use these things in the real world? And these are what the use cases are. So for example, in the financial use cases, people are using this LLMs, plus some part of not so much about knowledge graphs, but there are attempts in that, and Mike Bennett can probably throw more light on that, but I'm not sure he's there today. So the idea is to improve the communication for investment research. And the other one is that there's a lot of stuff going on, this portfolio management, investment decision making. And investors have certain preferences. And how do you map those investors' preferences into the portfolio management investment decision? And here you basically need both large corpuses of knowledge using LLMs to go through them, and also some symbolic reasoning. And the other part in financial world is the assisting preparation of accurate reports to the government regulators. Because if you look at many of the activities from the industries, they have to make reports to various federal agencies. And these particular systems like LLMs may be very useful in extracting the appropriate, to generate the reports. The problem with that is a lot of these reports could have hallucinations associated with it. So you need symbolic reasoning to kind of mitigate the hallucination. And again, Mike will be addressing that a little more. So that's for the financial use cases. Oops, I don't know, this one doesn't seem to work very well on the thing. In terms of the manufacturing use cases, we have a number of, I'm sorry about why this is not showing properly, but let me just get this thing down a little bit here. Okay. It so happened, I think it's to do with the font. For some reason, it suddenly changed the font to, let me change the font. Sorry about this, but can you see it? Ravi, can you?
Yes, we can
Yes,
see.
looks good.
Okay, I can use this font. It's okay. I don't know why I have to change the font. Okay. So here there are a number of applications which you'll be hearing. One is diagnosis, and we have a speaker who's going to talk about the well defect analysis. And in the building is a process in the manufacturing world. And then there's a lot of, the idea is to how to use both LLMs and then symbolic reasoning to do the well defect analysis. Then we have design. Design actually spans a lot of things, as some of you have been working in that. And we have both generative design of components, like for example, Fayez Ahmad at MIT is actually, he generates a lot of these bicycles using generative AI techniques, and he may be working in the in how to guide the search there. And I've asked him to see if he can give a talk. And the other thing which is very popular right now is material design. Again, Marcus from MIT has been doing a lot of work on integrating both the neural networks and category theory. Actually, it's an interesting application of category theory too. We have talked about that in the past. And they have come up with some really novel material designs so far. And I have requested him to speak, and hopefully he'll be able to talk about it. Then we have things like process planning. Layered manufacturing is a good example. Factory configuration. Maintenance is another example where you interpret the, like what happens is in a typical factory floor, you have a lot of these machines which are operating, and these machines are putting out a lot of signals, and these signals have to be interpreted in a proper way. And the way you interpret them is to use the reports which are in existence, and so you need both the neural and symbolic reasoning here. And finally, we have supply chain management, which is a pretty big field, and there are issues of optimization of the supply chain. And then you also want to query the user wants to query where is my actually a product in the supply chain, what's happening to it, what are the regulations that it has to satisfy, because when you go from one country to another country, there are a lot of regulations which needs to be satisfied. And so these things can be used in the manufacturing world. And finally, we have the healthcare use cases. And Todd, if you can chip in, you want to chip in some things, or you want me to go ahead? Anyway, I'm going
Go
to.
on.
Please press on, Ram.
Pardon? Okay. And then we are still discussing potential speakers, so I don't want to get. We don't have some of these things. We're still talking with various people on participating in the use cases. In terms of the healthcare, again, there's lots and lots of examples right now, and one of the things is we're going to have a use case on the mental health care, where again, in the healthcare, there's a wide spectrum of applications. There are the diagnostic type of applications. There are, again, developing plans. For example, in an oncology setting, you want to develop a plan for the cancer patient in terms of the drug treatment. So these things can be used for that. And also, the other thing that is happening is that it's a communication between the doctor and the patient. So you can help communicate with patients regarding various diagnosis, prognostic, and treatment decisions. And actually, the doctor can use the chat GPT kind of systems to generate summaries. But then again, these systems kind of hallucinate, as you know. So you need the symbolic reasoning to guide the doctor. Then you have things like drug design and pharmaceutical manufacturing. So we have a speaker already lined up for that who's going to talk about how LLMs plus the knowledge graphs are going to be used in the pharmaceutical manufacturing. And I'm also looking for some potential speakers on drug design. So these are the use cases. And let me see. I think that's about it. I think there's about 5 minutes.
Thank you. That was great.
So that's a very brief introduction to some of the use cases. Essentially, we'll be having three domains: the finance, manufacturing, and healthcare. In summary.
Thanks.
And the idea, and again, the idea is that these are not just people who are developing architectures and so on and so forth, but here are some pragmatic applications of this in the real world.
So the last track will be on risks and ethics. So there'll be one panel concerned with risks, and then a second panel on ethics. So we have not yet lined up the speakers for that, so I don't think there's really much we can say about that last track. But that's going to be coming much later, and we'll be posting the panelists when we get them lined up.
And Ken, on that, there is a AI risk management framework from NIST, and let me see if I can get a speaker from there, because that is the one which is being pretty much used by a lot of industries on managing risk. But then that one really deals with only kind of generative AI kind of applications. But I'm sure that they've been thinking about combine both the symbolic and generative AI.
Yes, I think. Have you lined up that speaker?
No, I'll talk to Riva. So I think
Right.
either she or someone from that organization will make a presentation, I believe. Okay, so let me talk to.
Okay.
Because they have
I
a
was-
system in there. So
Yeah, I was going to add about the risks that I think some of the risks could be focused on what I talked about in terms of hybrids and connections. And also within this track C, different application areas provide different risks, like in healthcare. So I think it's a natural that some of the aspects from the various tracks will be reflected in the risk discussion.
Yes. So with that, we have given an overview of the upcoming summit. So now I'd just like to briefly mention the future summit planning. We're coming up in 2026. At that point, we will have had 20 ontology summits, and it would be nice to revisit the topics of these 20 summits and then conclude with a face-to-face symposium. So I wanted to tell you about that. That's still 2 years from now, but the way things work with such such symposia. We really need to start planning it this far in advance. In the meantime, I will ask that if you have any suggestions about how to proceed with this, we would appreciate hearing from you. And I've actually already prepared a draft of the schedule for that summit, where there will be 1 or 2 sessions devoted to each of the 20 summits. And so in each of the summits, it'd be interesting to see what has happened since that summit, and to what extent did any of the plans and proposals that were made in those summits been actually carried out. So, any final questions? Let's move to a general discussion. Feel free to put a question in the chat or raise your hand.
I think we're going to have a very exciting session next week on with Gary Marcus and John Sova.
Yes.
Oh yeah, I hope so.
I would just say one thing about Gary Marcus is for next week is, as I mentioned, he's very much interested in what's called robust AI, but he and Doug Leonard had an article before Doug died on this very topic that is also worth looking at. And I imagine that, he will say a few words in that regard next week.
Okay. Ken, on that, we may have to send some reminders to Gary because he's a busy man. So, maybe send one sometime tomorrow or something like that, or maybe on Friday, so that he'll remember to put it on his schedule.
It's amazing that people like Pascal and others who have been working, and Gary, of course, is being mostly quoted by almost everybody. So these are pioneers, I guess. Ram, you can say more about it.
I mean, they've been thinking a lot about these things, both at a abstract level and a detailed level. So sometimes you have to talk to the lay people, and I mean, lay scientific audience in a way. And Gary is very good at communicating those, whereas Pascal is more in a technical sense. Okay, so he has got some very good. Pascal, Amit Seth, and all these people are at the very. I think Hamid also is probably going to talk about. The number of people are going to talk about it. John Sova, all these people have thought about it from a very in-depth kind of thing. So we will have their perspectives too. So I think we have a pretty good. In fact, Fabian worked at NIST before, and he has been looking into ontologies, but now also is integrating that into neural networks. That's pretty good to see. So we have. I think we have a very good set of speakers for this particular session.
On Pascal, unfortunately, he has a very hard commitment at this time frame that he can't get out of, so he won't be able to be physically here for those. He's provided some advice on speakers and things of that to me, at least, and so maybe over time he'll have a little bit more to say. People may know he's in the process of launching a new journal on this very area, so he's quite busy professionally. And
one of the earliest books also on the topic was edited by Pascal, right?
Yeah. We know him from the ontological work, but his original dissertation area, so forth, was this more of the neurosymbolic connection. So he's very happy to be going back to this. He's never really left it, but he was known for other things. But he's very happy now to be a contributor to this.
Thank you.
Anybody else? Hamid, do you have any comments?
Not at the moment, but maybe in the later sessions we will have a discussion.
Okay, and John?
Can I make a comment?
Oh, Chris, hi.
Basically, I'm in deep retirement. And 50 years ago, I was asked to design an interface for future integrated management information systems in the commercial world. And I did a bit of research, which was supported by a couple of the leading computer scientists in the UK, and then got quashed, for instance, because a patent had been taken out, therefore it was a hardware product, therefore the company that employed me was not going to invest in it. I'm now looking at this again, and what it appears to have been is that I'm neurodiverse, which means I tend to think in a different way to other people. I have aphantasia, which means I don't take any notice of what I would call the visual side. I concentrated on the symbolic side, and it now looks as if I may have accidentally reverse engineered how the human short-term memory works.
Wow.
I'm not certain. The problem, of course, is that from deep retirement at my age, I'm pretty sure that what I came up with could be described in terms of ontology mapping onto a network, where, okay, part of it is that the human interface, if you like, the human short-term memory, the system worked because it didn't have great big volumes of information. It worked with a short-term memory in the same way that a human does. And basically, I'm looking at whether this work is worth archiving or following up. There's no way at my age I can follow it up in detail. There's no way that I can read all your literature in your fields and get a grip for bits of it. But basically, the whole idea of what I was doing is to design a system which would act as an electronic clerk for ordinary people, not mathematicians, and that under no circumstances should it use any sophisticated mathematics. Now, when I say that, I'm not afraid of sophisticated mathematics. I actually did a PhD in theoretical organic chemistry, which involved quantum chemistry. So
Yeah.
I've done quite elaborate mathematics myself, but I've said a system which ordinary people can understand and which should evolve shouldn't dive into deep mathematics. That's all now. If anyone's interested, I can send details.
Okay, yeah. Sounds like you could use some collaborators.
I put it this way. I'm in the situation where at my age, I'm a carer for my wife. I'm not as mobile as I was. I don't, in fact, have an account with any university library, which means I keep on coming across paywalls.
Yeah.
Like research, and I'm very happy to contact anybody.
Okay.
Frankly, this is a novel idea to use the text processing to simulate or at least map what goes on in neural sector or mind. So great. Thank you. Kindly share in the email.
Let me, sorry to interrupt, but we've started to run a little over. So I feel we have to adjourn the formal meeting.
Okay.
And I hope everyone will be joining us next week.
Yes.
Um,
Shall I send you some details, Ken?
So just send me some details and I'll see how I can disseminate them.
Yes, certainly.
So thanks everyone for coming, and we will now formally adjourn.
Thank
I
you,
will turn
Ken.
off the recording.
Yeah.